In common law, there is a principle that goes, whoever's is the soil, it is theirs all the way to heaven and all the way to hell. Dated to the 13th century, it means that landowners have exclusive control over the airspace and subsurface directly above and below their property. However, with the advent of aviation, beginning with hot air balloon flights in the 18th century, this principle proved impractical. Today, property owners usually have rights to airspace anywhere from 500 to 1,000 feet above their property. A 1919 international convention in Paris set rules for national airspace rights, saying that every country has complete sovereignty over the airspace above its territory and waters. However, spaceflight further complicated the issue of air rights because satellites and spacecraft fly over many countries. Today, there is no settled definition for where space begins. Many organizations, including the World Air Sports Federation, use the Kármán line, which is 62 miles or 100 kilometers above the Earth's surface. The US government considers astronauts to be individuals who fly 50 miles or more in altitude above Earth's surface. Defining the boundaries of outer space is important because airspace between the ground and outer space is under the sovereignty of the country controlling the land, while outer space is considered to be common heritage of mankind. The principle common heritage of mankind means that certain areas should be preserved and forbidden from being claimed by any particular country or private entity. Examples include international airspace, international waters, and outer space. The primary international agreement governing outer space is the Outer Space Treaty signed in 1967. Negotiated early in the history of space exploration and during the height of the Cold War, the primary focus of the treaty was to prevent the militarization of outer space. The treaty explicitly bans weapons of mass destruction from being placed or used in outer space and prohibits the establishment of military bases. The OST also says that countries are not allowed to claim celestial bodies for themselves. Negotiated during a time when only national governments were operating in space, the Outer Space Treaty does not consider the use of space or celestial bodies by private corporations. In 2015, the United States enacted the Commercial Space Launch Competitiveness Act, making it clear that private companies can operate in space for profit. Keeping in line with the Outer Space Treaty, the US government did not attempt to assert sovereignty over space, but permitted companies to explore space and mine for resources like water and minerals. One of the most valuable resources in outer space might be something that is already abundant on Earth: water. Liquid water contains two elements vital for rocket fuel: hydrogen and oxygen. The Moon is believed to contain significant amounts of water ice that could be separated into hydrogen and oxygen for use as fuel. There are numerous technical challenges to making this happen, but the Moon's lack of atmosphere and lower gravitational force could turn Earth's natural satellite into a refueling station, among other things. In the future, rockets could launch from Earth and refuel on the Moon before heading to Mars, the outer planets, and deep space. Because of the Moon's gravitational advantages, those rockets would be able to carry more cargo and undertake longer expeditions. Water ice on the Moon is located at the poles, but will be difficult to extract as it is not in the form of glaciers. Instead, lunar ice is mixed with sediment and inside the shallow parts of craters. Even if it can be accessed, there is still the question of how this valuable resource should be shared. The United States plans to return humans to the Moon in 2025, in part to look for water ice, and the US has made clear that American companies can mine in outer space. But as other countries develop their space programs, there will need to be some agreement on the sharing of resources. Right now, the Outer Space Treaty says all of space is held in common by humanity, but countries and private companies using resources for their own use would seemingly violate that principle. Just like on Earth, there will likely be conflict between those who seek to extract resources and others who want to preserve the environment for scientific research or environmental protection. Researchers will undoubtedly want to explore regions of celestial bodies that humans visit in order to try and find life and understand the composition of those worlds. Mining, however, would disturb the natural environment and could potentially contaminate other worlds because there is no guarantee that traces of Earth-based life will not be left behind. If humans do manage to travel to Mars on a large scale, for example, there would likely have to be agreements in place setting aside certain regions for mining and others for scientific research. But if water does become a valuable commodity in space, the issue would be that any potential extraterrestrial life would likely be where the water is, since water is the basis for life on Earth. Any action to extract water on other worlds may make it difficult to properly search for life, so policymakers will have to form a consensus on how to balance the competing aims, economic development, and scientific research. All of these hypotheticals will likely take decades to play out, as humans have not left low Earth orbit since Apollo 17 nearly 50 years ago. In recent years, the focus has been on satellite launches and the International Space Station. Overall, the number of launches per year is now slightly fewer than the 1960s and 70s, but the cost per kilogram of cargo is much lower due to advancements in rocket technology. Currently, there are about 6,000 satellites in orbit, and thousands are expected to be launched this decade. These new satellites will be used to improve communication, Earth imaging, and our knowledge of space, but all of these satellites are being launched into crowded real estate. Of the nearly 6,000 satellites in orbit, about 60% are no longer operational. There are thousands of pieces of space debris orbiting Earth, ranging in size from rocket boosters to tiny pieces of metal. Space debris poses a threat to satellites, and some have even been destroyed in collisions with other satellites. Countries have also made the problem worse by deliberately shooting down satellites to demonstrate their military capabilities. The United States, Russia, India, and China have all shot down defunct satellites, creating thousands of pieces of space debris. Despite the growing problem, there are no agreements in place to clean up space debris because it is not technologically feasible. However, many satellites are now launched into a specific orbit so that when they become defunct, they will fall into Earth's atmosphere and break apart. Another consideration for artificial satellites is that not all orbits are created equal. One of the most valuable orbits is called a geostationary orbit. Satellites along the equator that orbit at the same speed as Earth's rotation are in geostationary orbit. Satellites in this orbit are always exactly above a fixed point on the equator, and those that connect with ground antennas are ideal for geostationary orbit because the antennas do not have to move. They just stay pointed at the satellite. As such, many countries want to place their satellites in a geostationary orbit, but availability is finite. Because all geostationary satellites are orbiting on the same plane, there can only be so many before they start interfering with each other. In 1976, 8 equatorial countries signed the Bogota Declaration, claiming that geostationary orbits are a resource that countries on the equator should have control over. Asserting sovereignty over a certain orbit again raises the question of where space begins and where sovereignty ends. But besides the Bogota signatories not being major space powers, orbits, including geostationary ones, are considered to be outside the jurisdiction of any one country. On Earth, for example, many countries control important waterways, but have little control of who passes through them during peacetime. Turkey controls the Bosphorus and Dardanelles Straits, which connect the Mediterranean and Black Seas, but ensures free passage for civilian vessels because numerous countries rely on the straits to access the open ocean. Also, parts of Antarctica are claimed by several countries, but international consensus says the continent is shared by humanity and should be used for scientific research. Just like international waters, Earth orbits and celestial bodies are and can be useful to humanity, and as such are considered to be shared by everyone. It is plausible that countries will establish their own bases in outer space, but like Antarctica, the region will likely continue to be regarded as common to humanity. Countries may pursue their own goals in space, but sustained presence there will require international cooperation. Currently, the most ambitious space project is the International Space Station, built by numerous countries, including two rivals, the US and Russia. America's plan to return to the moon with the Artemis missions is predicated on support from partner countries. If space exploration continues to be an international effort, there may be more agreement on how to share space resources. Private companies might operate more autonomously, but at least in the short and medium term, they will still have to follow laws and regulations set by governments. Clearly defining the allocation of space resources can help prevent a tragedy of the common scenario. If any public good is exploited without limit, it will be exhausted and everyone who relied on it will suffer. Earth orbits are a common resource, but space debris and existing satellites could make it difficult to launch new satellites or even spacecraft in the future. Setting boundaries for where scientific research and mining are allowed could preserve the ability to learn more about space, while also making it possible to continue exploring space. Launching rockets from the moon requires less energy than on Earth, so using resources on the moon could allow humans to explore more of space. At the same time, there is much we do not know about the moon, and scientists will want to study it. Effective governance of outer space will be critical for exploration. If countries want to use resources, they will have to agree on how to share them in order to prevent conflict. If companies want to raise money from investors, there will need to be clarity on what companies are and are not allowed to do. A Wild West scenario would likely do more harm than good and hurt the incentives for space exploration. Because it might take decades before sustained human presence on the moon or planets is possible or probable, there is still time to set boundaries for activities like mining and colonization, but there are pressing matters related to satellites and orbits just a few hundred miles above us. Space already functions as a platform for vital technologies like GPS, communication, climate monitoring, finance, and weather forecasting. If done correctly, the proper regulation of activities in outer space could result in a new frontier for human innovation and development.